Okay, this is the last section in this chapter, 8.4, and we're going to read and write numbers in scientific notation. So, very big numbers, like 1 million for example, and very small numbers, such as 0.0009, are written in standard form. So when we see them that way, that's the standard form for writing those numbers. But another way to write them is to use scientific notation. So it's kind of a way to more easily deal with numbers that are very large or very small, so that then when we go to multiply, divide, add, and subtract, it makes it a little easier. So a number written in scientific notation is of the form c times 10 to the n, where c is an integer. C is between 1 and 10, and n is an integer. So for example, 2 million could be written as 2 times 10 to the 6th, and what we've done there is taken the decimal point and moved it 1, 2, 3, 4, 5, 6 times, so that we're just left with a number between 1 that's greater than 1 and less than 10, times 10 to the 6th, because that's how many times we moved it. 5 thousandths, going the other direction, can be written as 5 times 10 to the negative 3, because we move the decimal 3 in the other direction. Okay, so for example, if we're given numbers in standard form, we can write them in scientific notation. So first we have 267,500,000. So we are going to take the decimal point and move it until we get to the 2. So 1, 2, 3, 4, 5, 6, 7, 8. So we have 2.675 times 10 to the 8th. Now going the other direction, if we have 0.000486, we can move the decimal until we get to the 4. 1, 2, 3, 4. And that's 4.86 times 10 to the negative 4. Alright, so this is what we're more interested in. When we are given numbers in scientific notation, or when we put them in scientific notation, it makes it easier to multiply them, for one example. So if we have 8.5 times 10 squared times 1.7 times 10 to the 6th, we can multiply. So think about what we know about multiplication, and it's commutative. So really, this is the same as 8.5 times 1.7 times 10 squared times 10 to the 6th. And now it's just like our other rules of exponents. So when we multiply 8.5 and 1.7, we get 14.45. And then 10 squared times 10 to the 6th is times 10 to the 8th. But then, remember, we're supposed to just have one number left here. So really, I need to make this 1.445. Well, think about, we just moved 1 to the left, so that's going to become 10 to the 9th. And that we can also do in our calculators, but just so you understand where it comes from, we can also do it by hand. Okay, for another example, if we have 1.5 times 10 to the negative 3 squared, again, our same rules of exponents apply. So that squared needs to be distributed inside the parentheses. So we end up with 1.5 squared times 10 to the negative 6. So that's 2.25 times 10 to the negative 6. Okay, and for our last example, again, our rules of exponents still apply. This time we're dividing. 1.2 times 10 to the fourth over 1.6 times 10 to the negative 3. So here we're going to divide 1.2 and 1.6 just like we normally would. So we end up with 0.75. And remember, if we have a negative exponent in the denominator, we can put it in the numerator and make it positive. So 10 to the fourth times 10 cubed, well, that just becomes 0.75 times 10 to the seventh. But again, remember, scientific notation means we need to move that decimal here. So we end up with 7.5 times 10 to the seventh, and then times 10 to the negative 1, because we went one direction to the left, or one decimal point to the left. So then we end up with 7.5 times 10 to the sixth. And again, everything we just did, we can also do in our graphing calculator, but it's important that you understand what the calculator is doing so that if you type something in wrong, you can guess that something probably went wrong and you can check by doing it by hand.